Okay, this is a triangle, as you can see, right? Let's say the height of the triangle is 1, and let's say the base is 1. All right. So you want to get and that's obviously has a slope. That's like an incline. If you were going up that, that's fairly steep. This one isn't. All right. So how do you measure the steepness? All right. And that's what a slope of a, let's say, that is a, let's say it's a road, right? How do you measure the steepness of it, right? So the measure of steepness is y over x. Okay, so if that size is 1 and that size is 1, you got 1 over 1, so that steepness is 1. The steepness of this one is, let's say y is 1 and x is 2, it's a half. So a half is much steeper than 1. Okay, it would be you'd think it'd be the opposite way around, but that's just the way it works. So when you say, God, it's very steep, well, actually, no, hold on. I mean, what I mean, this is shallower. So it's a half is less than 1, therefore it's shallower. It's not as steep as this one. Okay, that's basically it. All right. So it's a measure of steepness. That's what a slope is, right? So it's a ratio of a y value to an x value, which will give you steepness. Steepness also translated, and all these words is also slope. Okay, the size of y to the size of x is also a ratio. All right. The change in y to the change in x is also another way they express that, right? Uh, uh, and that I'll come to that in a second, right? So you can have a slope of a half or slope of 1. Slope of a half is not as steep as a slope of 1. So that's basic concepts, okay? So it's a ratio, right? So if I was to have a curve right there, and I'm going to draw a tangent from there to there, right? And that skims the point at that point. I want to know what the slope of the tangent to this curve is. So really, it's just a ratio of y to x, right? That's all I want at this point, right? So if I drew a tangent manually, right, and then I got this point here, figured that out manually, using a compass or whatever it is, and I got that point, then I could measure the y and measure the x, and then I'd get an idea of the slope of this tangent. That's one way of doing it, but again, you'd probably make errors and it would be very difficult to do. So the way you do it is that you need, see, if I have a point there and I want to get the slope of the tangent there, and then I want to get the slope of the tangent there, and I want to get the slope of the tangent there, I have an equation for this from the previous example I just sent you, right? So how do you get the slope at like any point? Well, you do differentiation, right? That's the whole idea. So you'll get a formula, right? And I think we ended up with what was it? I think it was 2x minus 3 after we differentiated, right? So that's a formula, okay? So I could plug in any x value and I will get the slope at that point. I put that x value in there, that x value in there, that x. So when we differentiate, we had the original curve and we ended up with this, okay? That's dy dx, okay? Which is the rate of change of y with respect to x, which therefore is the slope. So the rate of change of y with respect to x again is the slope at any stage. Okay, now in Greek, this symbol here, right? It's like a triangle. It actually looks like one of them. That's a nice way of looking at it. It actually means delta, right? Delta in Greek means change. So you got the change in y over the change in x, which is a measure of slope. Okay, now instead of putting delta symbols in, which is very difficult, they put in d. So that's how you get dy dx. That's the delta y delta x, which is the change in y over the change in x, which brings you back to this. So now you know what slope is, okay? And then conveniently, if you have an equation, you can get, if I was, let's say, if I was just to give you, if I was to tell you, look, the slope of the curve is at one point is there, and then it's there, and then it's there, you'd have a pretty good idea that the curve that it's doing goes like that, because you know it's going to bottom out at there because the slope is 0. It's not changing at all. It's flat. Delta y over delta x is 0 at this point. Rate of change of rate. So they're interchangeable concepts that you have to know how they all translate into each other. Otherwise, you're going to get confused. Okay. So we came up with this equation. That's an equation which is related to the original equation that will give you the slope of the tangents at any point, and that's all it is. All right. So then you can plug in your points at any point. Don't get confused between this equation, and the original equation which we had. I think it was what wasn't it? It was x. It was x squared minus 3x plus 2. Okay, so when you differentiate that, you get this. They're two different equations, though they are related. And you can go from that to that. You can also go from that to that, which is integration. That's another chapter. But you need to know what slope is, what d is, and how to read all of this, and you should be okay. Okay, and that's all it is really for the moment. Okay.